1.10b, piecewise functions and step functions. Today, you will be able to construct a piecewise function, you will graph piecewise functions, you will analyze and relate characteristics of piecewise functions to applicable situations. To graph a piecewise function, we can graph the functions that make it up, cut them apart according to the x intervals, and then place the portions together. So looking below, in our function, you can notice that we have two equations written next to this function notation with this fancy little squiggly bracket. The first function is negative 2x plus 1. So you can see right below this, the blue graph that is drawn is y equals negative 2x plus 1. If we then took a scissors and cut our graph where x is less than 2, we would only keep this left-hand portion of our graph. When we look at f of x equals x, or the equation y equals x in red, and we graph that line on our coordinate plane, we have to pay attention to, we only want the piece of that red graph where x is greater than or equal to 2. So if we took a scissors and cut our graph at that point, it would be only the portion of our line that is greater than or equal to 2. So when we take those two pieces and place them on our third coordinate plane all the way to the right, notice that the left raised endpoint is not included. So looking at this blue endpoint, you see that there is an open circle, and that is because in our restrictions, it was just a less than symbol. So we want to make sure we have an open circle. Looking at the right, or the red graph's endpoint, you can see that it is a closed circle because that endpoint is included, and that is notated by the or equal to underneath your greater than symbol. So you take two graphs, and essentially you are cutting the pieces that you would like and placing them on your third coordinate plane all the way to the right. So example 1 says graph the piecewise function. So what we are going to do is we are going to graph this top equation first. F of x equals x plus 1. So we know that our y-intercept is positive 1, and then my slope is an invisible 1 over 1 in front of that x. So what I do is I plot all of those points from one end of my coordinate plane to the other, and then we're going to erase the piece we don't want. So we want all the values where x is less than negative 2. Notice that it's just a less than circle, so where x equals negative 2, find that on our equation we want to make sure we put an open dot, or on our line, excuse me. We then want all the values less than negative 2, so that's going to be everything to our left. Then looking at the second part of our function, we have 1/2 x, and remember there's a plus 0 after that, so we're starting at the y, or the origin, 0. We are going to rise 1, run 2, so if we put these dots on our graph, and we only want the values that are greater than or equal to negative 2. So find negative 2 on your x-axis, you're going to put a solid circle, and all of the dots greater than or equal to 2 are to the right. You then want to get your eraser and erase all the pieces or the dots of the lines that we did not use. So you just graphed a piecewise function on your coordinate plane. It then asked us to state the x-intercept and the y-intercept. You can see that we crossed the x-intercept at 0, 0, and we also have a y-intercept at 0, 0. Our blue line will essentially not cross that, but when we state the x and y intercepts, we want to state them for the entire piecewise function. Example number 2, we're going to write the equation for the piecewise function. So let's start with this first piece has a solid dot and goes down to our left. So if we look at our y-intercept, we can tell that our y-intercept is at 5. So write our function notation. Do your little squiggly. We have a y-intercept of positive 5. If I look at a specific point on my graph, we'll say this, and draw my slope triangle. I am rising 4 and running 3. So my slope is 4/3 x. Now when we look at our line, we want all the values to the left of 0. So we say x is less than, we want to use an or equal to because it's a solid dot, 0. Looking at the next line, we notice that it is a horizontal line. So a horizontal line is y equals wherever that crosses your horizontal axis. So in this case, it's 2. We then look at our x-axis for our restrictions, and we know that it is also 0, and we want the values greater than 0. This endpoint is open, so it is not included. So we just leave our restriction, x is greater than 0. Now looking at where our function is increasing, if you look, this red line would continue to negative infinity, so it is increasing from negative infinity all the way till 0. So a parenthesis around negative infinity. It is a closed dot at 0 on our red line, so we want to use a bracket. Where is our line constant? So if we look at our blue line, that is where our line is constant. It's starting from 0 on the x-axis, but it's an open circle, so you want to use a parenthesis, not a bracket. And it's going to positive infinity. Again, use a parenthesis instead of a bracket. And then our range, we're going to look at our y values. What is the lowest y value our graph goes? So again, this line's going to negative infinity. So a parenthesis, and the highest our graph goes, if we put a horizontal line on that point, would be positive 5, and it includes that point with this solid dot right there, so we put a brace. You just successfully graphed your piecewise function. Example number 3 says, at midnight on a cold winter day, the temperature was 4 degrees Fahrenheit. And the temperature fell 1 degrees per hour until sunrise at 6 a.m. After that, the temperature rose steadily at 2 degrees per hour until I stopped checking at 10 a.m. Graph the piecewise function, write its equation, and what is the minimum. So looking at this information, we need to label our axes. So my temperature in degrees is going to be on my y-axis. My time starting from midnight, so 12 a.m., 1 a.m., 2, 3, 4, 5, 6, 8, 9, 10 goes along my x-axis. So they said we started at 4 degrees at midnight, and we fell 1 degrees per hour until 6 a.m. They then said at 6 a.m. our temperature rose 2 degrees per hour until we stopped checking at 10 a.m. So to write these two equations, looking at the blue line, we can easily see that our y-intercept is at 4, and we know that we went down 1 degrees per hour. So from 12 o'clock a.m. to 6 o'clock a.m., so we're going to have 12 a.m. is less than or equal to x, which is less than or equal to 6 a.m. Looking at our red line, if we continued to go down 2 and left 1, we would be at negative 14 degrees Fahrenheit. We know that our temperature is 2 over 1x, so our slope is rise 2, run 1. From 6 o'clock, so 6 a.m., is less than or equal to x, which is less than or equal to our 10 a.m. where we stopped checking. You just graphed a piecewise function and wrote an equation. It then asked us what is the minimum. So what is the lowest temperature that our graph touched? So it would be -2 degrees. You now can complete your homework.